get rolling. So we finished up with drill bits, drilling path. So you should have been able to write a drilling path. Don't forget to upload that. Now we're going to look at the two other most common tool paths, and then there's a fourth less common we'll go into next week. But these next two paths are the most common. So I think I want what do I want here? How about this guy? So I'm going to open SolidCam. See if it's done opening here. Done opening. Alright, just so it doesn't auto-save somewhere, I'm going to change it. Alright, and then this did not save my drill operation from yesterday, but it did save my cam part definition. So I've got my machine, my coordinate system, my stock, and my target. Now what we're going to do is talk about two different toolpath operations. The first one we're going to talk about is pocketing. So we've had drilling. That's very important. It's very common to drill holes. Now we're going to talk about pocketing. And what pocketing means is taking a closed boundary and chewing out everything inside that boundary. So it's important that when you select your geometry that it has to be closed. It must be closed up, or the software is not going to understand what you want to chew up. So let's write one. So we'll right click, add milling operation, pocket. Alright, again we have our name. Now this is going to look similar to the drilling pass, but there's going to be a lot more options. First thing we need to do is select geometry, of course. What are we going to pocket? Alright, so I want to pocket this rectangle. So I'm going to grab this line, this line, this line, this line. It's not grabbing it. This did this to me yesterday too. No, something's goofy. It should just select it. I wonder if my target's messed up. I'm going to cancel this operation. And SolidCam's missing. Well, that's interesting. Okay. Whoa, this is going nuts. Something's crashing here. Whoa. Wow. I'm gonna have to restart here. That was ugly. Alright, let's see if it wants to play now. Alright, just to be safe, I'm going to go to my target. Sometimes it loses its target. Just redefine that. And then let's try this again. Add milling operation pocket. I'm going to go to geometry. There we go. So the line turned yellow. Now I've just got this one line. And I want you to notice here this arrow. So this is telling us what direction the pocket is going to move in. That's going to become critical in a bit. Alright, so I'm going to finish closing this boundary by selecting these four sides. And it knows that we closed it up because it knows that we made that last point, and it's asking, is it okay to accept this chain? Yes. They call these things chains because you're kind of daisy chaining edges together. Alright, so there's one. You can see this is chain one, and it's red, so it's complete. I want to add another chain. Now notice how I did I selected 4 lines. I could also do auto constant Z. So if I select this chain, it's going to automatically select, and it's going to stay at a constant Z depth. So I grab that, and it should go all the way around. Of course it didn't. Well, it should, but it didn't. And now it's giving me a hard time. Oh, there it goes. Auto constant Z, so it jumped around. I think my computer's just bogged down here. Probably should have restarted it. Okay to accept, yes. And you can see there's chain number 2. Alright, so it's going to pocket out, which means within these 2 boundaries, chew up all the material inside. There's my geometry, and I can accept it. Alright, tool. Now, we're going to use different tools. You've been introduced to end mills, and you've used them on your little cubes. So let's go ahead and select a tool. And we don't have any. Well, there's that drill we used yesterday, but we need to add a tool. And this time it's going to be an end mill. Now, this is critical you have to decide what diameter you need to use. Now, there's a couple of constraints. So first of all, that end mill has to be what? In respect to this dimension, which is 0.5118. It's got to be smaller than that, right, to be able to fit in there. And then the second consideration you need to make is how big of a radius will that tool leave? Remember, this is a square pocket, but we have a round tool. We'll see that in a bit when we solid verify. I'm going to go ahead and use, since this is a pretty thin plate, I'm going to use a pretty small diameter tool. I'm going to use an 1/8 inch diameter end mill. Again, you could fill in all these other parameters if you wanted to have a very nice graphical representation of the tool, but for us it's a waste of time right now. What isn't a waste of time is your tool data, your feeds and speeds. You should be able to calculate these based on the formulas that we've given you. I'm going to go ahead and go 7 inches a minute in X and Y. Now, unlike the drilling paths, does the X and Y matter this time? We're taking an end mill. We're going to come down and we're going to cut metal as we go around in X and Y. So feed XY matters a lot here. I'm going to go 7 inches a minute, and it's slow because it's such a small diameter end mill. We don't want to break that end mill off. Now feed and Z also matters because in this case we're going to plunge down into the material. Now if we're going to plunge straight down into the material, we need an end mill that is, do you remember from the tooling lecture? It has to be center cutting in order to plunge down. If it's not center cutting, you must use a ramp or a helix to cut in. So you got to be careful with end mills plunging down. They're not designed like drill bits. Drill bits are designed to plunge down and take axial cuts. End mills are designed to cut radially from the side. All right, so you want to take it easy on these plunges, they're called, into the material. General rule of thumb is about half the feed of your XY. So I'm going to go on the order of 3 or 4. My spindle speed, because it's a small diameter end mill, is going to be fairly quick. I'm going to put 3,500 in here. And again, coolant is your other option. All right, so we have our tool. Now we go to levels. Here's where you're going to see quite a few different parameters from the drilling operations. Okay, we still have our start level and our clearance level. Still have our safety distance, upper and pocket depth. Now the pocket depth is 0. The machine doesn't know how deep I want to go. How deep do I want to go? How deep do I want to go in this pocket? All the way through. So let's click the pocket depth. Let's flip it upside down. Click the pocket depth. There it is. And now here's something that's different. We have step down. So the step down, if you click the box, you can see in the picture, it's going to do that pocket, which is 78 thousandths deep, in steps. And we need that. It's really important. That 1/8 inch end mill is going to have a hard time with taking 80 thousandths. Okay? You definitely shouldn't be taking more than half the diameter of an end mill just about at any time. So half of an 1/8 is a 1/16, which is about 62. So this would be well over that. But as you get smaller in diameter, that less than half gets even less. You want to take it easy on the that end mill because it's kind of wimpy. If you look at an 1/8 inch diameter end mill and you kind of flick it with your finger, you can flick it. You could probably break it with your fingernail if you were tried hard enough. So we want to be not so aggressive here. So I'm going to take, let's say, 20 thousandths cuts. And if you want to hit equal step down, you can hit equal step down, and it'll take this pocket depth and divide 78 by approximately 20 thousandths into equal steps. But it won't go over 20 thousandths. So we're probably going to end up with I don't know, 17 or 18,000 steps, something like that. We'll take a look. All right, let's go to our technology. All right, now we have a bunch of stuff. All right, overlap, okay? If you look at overlap, if you've ever mowed a lawn, that's what this is like. When it goes to pocket, it's going to take one step, move over a little bit, and keep going. When you mow the lawn, you want to overlap a little bit, right? So you've got the width of the lawnmower, you got another width over here, you overlap by a little bit. Well, you can do it either by the percent of the tool diameter or by a hard-coded value. In this case, it's got 50%. I'm just going to leave that just for fun. The important parameters, the most important parameters are over here. These are the offsets. The wall offset. Now, when we talk about wall in a pocket, we're talking about this region here. This region here, these faces. Okay? When we talk about floor, we're talking about this down here. Now, in this case, do we have a floor? There's no floor. If I was to be a little guy standing here and jump into this hole, I would fall through because there's no floor. But in lots of cases with the pocket, you want a floor. There's pockets that you don't want to go all the way through. All right, so that would be the floor. And then an island is if you had an island within a part. Okay, we don't in this case. So this parameter doesn't matter to us. Wall offset does, though. Here's our wall offset. Now what this will do is if you put an offset in here, it's going to offset the tool a little bit away from that wall and leave this, see this little orange portion, it's going to leave that there. We like that because we'd like to come back through and do a smaller finish cut right there. If we take these huge cuts, these big swiping cuts through here, that's going to cantilever our tool and bend our tool. And it's going to make the surface look kind of yucky. If we come back later and take a very small amount of material, the tool won't bend as much and it'll make this look quite a bit nicer. So I'm going to put a wall offset of something very small like 5/1000ths of an inch. I'm not going to put a floor offset because we have no floor. We're just going to go through. Now it asks me, do I want to finish? Yes, I want to finish the wall. Do I want to finish the floor? No, there's no floor to finish. All right, when it asks for depth on my finish cuts, do I want to finish every step of the way down? Remember, I'm going to step down, say about 20. Cut out everything in the middle, go another 20, cut it all down. Do I want to go 20, cut everything in there, and then do a finish cut? Go 20, everything in there, then a finish cut, 20, everything in there, finish cut? Or do I want to go 20, 20, 20, 20, and then when I'm done, take one last finish cut? Well, you can choose either. In this case, I want to do the finish cut at the very end because this isn't very thick. So I'm going to do a finish cut only at the total depth. There's some other parameters in here. If you look at these tabs, if you do this contour tab, you can start chewing this stuff out from the inside or the outside. I want the inside because I want to get rid of this material before I get close to the wall. You've got a direction, climb and conventional. Have you guys gone over climb and conventional? We're going to go over it again when I simulate this. So right now it's asking to climb. And there's some advanced stuff. We don't tend to use that too often. Let's go to link. Link is a different one from drilling. In this case, we have a couple of parameters that we may want to use. One is ramping, okay? The ramping is when you don't have a center cutting tool. And so we right now have programmed it. We're going to go down in and move around, plunge in, move around, plunge in, move around. Ramping is if you don't have a center cutting tool, you come down and you ramp down into your depth. And then you cut around, come back, ramp down into the next depth, cut around. You do that with non-center cutting tools. We also have a lead in, lead out. Let's go ahead and program one of those. If we don't lead in, lead out, what's going to happen is this tool is going to come down. In fact, let's just do it. Save and calculate. Let's go ahead and simulate. I want to show the tool in the holder. And I want to show, let's not show data. Well, let's show data. All right, I'm going to step. It's starting on my first pocket over there. And if you watch the data, it went 19.7 thousandths. And then it's going to go around. And now it's almost done with the pocket. See, it's overlapping like it's mowing the lawn. And then it's going to jump up. It's going to come down and go to the next depth, 39.4. And it's going to go around. Jump up, go to the next depth, 59.1. It runs around. Jumps up, next depth, 78.7, which was the final depth. All right, now I'm going to go ahead and hit play, and it's going to do the rest. I'm going to stop it at its last cut so I can show you the finished cut. So it's pocketing, pocketing, pocketing. Then it jumps up, and it's going to come back down. And watch, it's going to. We restarted it. I'm sorry. Let's go ahead and go to solid verify. So you can see it. I'm going to slow it down and hit play. Here it is, plunging at 39, plunging at 59, plunging at 78 all the way through, and then a finish cut. Did you see that finish cut? Watch it quick. 19, 39, 59, 79. Watch at the end. It's going to go around one more time. Bam. It went around one more time. Now the only reason it doesn't show through is the graphics card. If you, it'll actually be through, but if you wanted to see it through, you could program a delta in there of a couple of thousandths. So let's close this. Let's just do that so you can see it. Let's do a negative delta of a couple of thousandths. Now I want to show you the lead in, lead out. Notice that when it did its finish cut, when it was done pocketing, it just ran around and did its finish cut. That's okay, but the tool is going to come down and start right on that edge and run around and lift up off that edge. We will have tool deflection there. Remember, all tools are cantilevered beams. So if this is my tool, and this is my wall I'm cutting, the tool will either deflect this way or this way, depending on if you are cutting climb or conventional. This one is climb. Okay, the tool deflects away from the part, so the cantilevered beam will bend that way. Now that is preferable in almost all cases because you will end up leaving a little bit more material, and leaving more material is better than not having enough. You can always take material away. You can't always put material back unless you're Byron. He can put material back. Watching something else. Really fun to make fun of people when they're not listening. Okay, so climb, we want to climb so we can deflect the tool. The thing is, if you come down, regardless of whether you're climbing or conventional, if you come down right on that edge, okay, this end mill is going, as it's cutting, is going to wobble a little bit. It's going to shake back and forth. Very, very small, but it's going to shake as it's impacting this surface. Remember, end mills are not designed to plunge down. They're meant for radial cuts, not axial cuts. So as it comes down, it's going to kind of shake here, and it's going to leave what's called a blend mark. Okay? We don't want that. So what we'd like to do is enter the pocket or enter the wall from inside, and that's our lead in, lead out. You can pick the way it enters, either normal or arc or tangent. Let's do an arc for fun. If you look at this, the parameters, the tangent extension is how long it's going to take to move in here. Remember, we don't have a lot of space here. This is only probably about an inch, so don't get nuts about that. Let's make it move in 0.1. The radius is the radius it's going to use to complete that arc. 0.1 sounds okay. Let's make it 0.05. And then the arc angle, let's keep that 90. And then let's make the lead out the same as the lead in. All right, let's save and calculate that. And then let's verify that guy. So we'll simulate it. So we'll step. Again, now it's at 16. That changed because I added a delta, so it recalculated its depth cuts. So it's at 16, then it goes to 32. 48. I go ahead and play. 64. 80. So that's its final cut, its final pocket. And then it should lead in and lead out for this finish cut. So watch the tool. See it? It led in, and as it comes around, it leads out. That will all but eliminate that blend mark because the end mill's coming in a radial fashion. Questions there? All right, let's go to Solid Verify, and I'm going to quiz you here. Let's see who's on the ball. Watch this direction of cut. Am I climbing or am I conventional cutting? I'm climbing. This is really important to understand. So the way I'm moving around, here's my pocket, and here's my tool. Okay. And my tool is spinning clockwise. And I'm moving in this direction. All right. So as I'm moving, the cutting edges are hitting the part like this. So if I was to rotate this box up vertical, it would be like this guy here is climbing the wall. Okay. If I was to go this way, I would be conventional cutting because my cutting edges would be scooping into the wall this way. Make sense? Okay, also notice this from your Solid Verify. Look at the fillet that's left in the corner. That's because it's a round tool in a square hole. So you need to be careful when you select end mills. Let's go back to the tool. I could have selected a different tool, and made it a 1/2 inch end mill, saved and calculated, the lead in lead out didn't work because the tool was too big. So I'm going to go back to the lead in lead out and get rid of it just for argument's sake. Okay, now this is giving me an error. 2 lead in lead outs were not done because of lack of space. This is a bug. So I selected a 1/2 inch tool and I've only got just barely over a 1/2 inch of space, and I asked it to leave a wall for finish. So if you add the finishes on the walls and you add the diameter of the tool, it can't get in there. So I'm going to have to go back and make another tool that isn't quite that big. Let's go with the 3/8 tool. Then I save and calculate. That one worked. Now if I go to Solid Verify and run it, look at my fillets. They're much bigger. Okay, so the smaller the tool you get, the smaller the radius you get in here, and the closer you get to square. But the smaller the tool you get, the smaller the depth cuts you could have to take, the slower you have to run. So you're trading time for finish. All right, questions? Now, yeah.
Is the extra amount of time you would take with a smaller drill bit? Like,
End mill.
What or right? Yeah. Would it be worth it to cut with a big drill bit and then change the tool and put a small one in there?
Yeah, that's common. You wouldn't do it here because it's such a small pocket. But what if this thing was 10 by 6 inches? You might come in and hog all that material out with a nice big end mill, like a 3/4 inch end mill, and then just run around the outsides with the small end mill to take out this little fillet. Yeah, that's real common. Yep.
Will this thing predict how long it'll take for it to run?
Yes, it will. And that's under data. That's a great question. So look what it did here. If I run this path, it predicts right here that it's 4 minutes 55 seconds. Now, that is only as accurate as the parameters that we entered. So it is using the feed rates of the end mill to calculate that. What it's not taking, what it also takes into account is the rapid moves. So those rapids, that rapid speed has to be accurate with the machines that we have. It probably is not, because I don't think we went into our post processor, clocked our speed on our machines, and then hard coded the rapid feed rate of our machines. So it's probably off a little bit on the rapids, and then it's also off on tool changes. Okay, so it's going to guess at a tool change time based on what it thinks that the machine can change its own tools. That's not the case. You will be changing the tools. So how would the program know how long it takes you to change a tool? It could be 20 seconds. It could be a half hour if you were at class, right? Or an hour. So it doesn't know that. So this is only an approximate. But they're fairly good.
It's actually a program of 3 hours.
That's right. And you will end up doing that, especially in 3D surfacing, which we'll go into next week. It's going to be very important to change parameters around to reduce your time, because you'll end up making 10-hour programs. Okay, great question. All right, let's see here.
Oh, I did have another one.
Yep.
Your the clearance level for safety distance. I guess clearance level and safety distance.
Yes.
Are those both? I guess the clearance level, the height that it will travel to your point at. So like for me, following with you, but just with base plates, so it only has one hole. So is it going to travel across the mill at that height, or is it going to be high like at the tool start level, and then that clearance level is just between holes that you're.
Okay, so yeah, it's this, so in this case I have two pockets, right? As my clearance, the tool start level is where it starts when it first starts this path. Then it rapids down to the clearance level, which happens to be the same in this case. That's not going to take very long.
Yeah.
And then it rapids down to the safety distance, which is 0.1. And then it moves at the feed rate in Z, which I set, I believe, at 3 inches a minute, and cuts this pocket. When it goes to the next pocket, it's going to jump to the clearance level, jump up to 5, move over, and do the same thing. All right, questions there?
Oh, yeah. Do you need a delta for? I guess you do have a delta for your pocket depth.
I would not use that delta. The only reason I'm putting that delta in there is so that you can see that it went through the material. If you set your tool zero at 0.078 and that's the top of my plate, and then you tell SolidCam to go to 0.078 deep, your tool is going to go to my plate, and it's going to cut through your plate and just barely touch my plate. So I just put that in for visual sake. Okay, any questions there? Pockets? All right, that's pocketing. Very, very common. So we've got drilling, pocketing. We'll go to the third most common, which is profiling. All right. A profile in SolidCam is similar to a contour in other machining programs, so that the nomenclature is a little bit different. But basically what a profile is selecting a non-closed contour, just an edge or a series of edges, and telling the tool, just follow that edge. That's it. Just follow this edge. So in this case, remember on this piece, we were going to cut two sides, right? Move the clamps and then cut the other two sides. So in this case, we want to use a profile. So let's right click, add a milling operation. Let's use a profile. We're going to select our geometry again. And I'm going to select here. Now, why did I start here and not down here? I want to cut these two sides. Why did I start here and not down here? It shouldn't really matter. I mean, the tool can cut either way. Has to do with the fact that the tool is spinning clockwise. This will climb. Tool is spinning clockwise. Climb, 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 climb. If the tool is spinning clockwise here, I'm scooping, 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 scooping. So I want to climb here. All right. So I'm going to select around this edge. All right. It said gap exceeds minimum value. So what happened was I selected these two edges, and I must have selected a line that's not connected to this line. That's a problem with profiles. It's got to, every line has to touch every other line. All right, so I'm going to be careful this time and make sure I'm grabbing the right lines. They turn yellow as we go. And I think I'm going to stop there because I want to show you lead in, lead out on this. I'm just going to do this side. Then when we move the clamps, I'll do this little cutout. Okay. So now I'm going to go over to my chain list and say, hey, I accept. And it's going to let me do it and turn it red and call it chain 1. It lets me do it because it's a profile. This would not work if it was a pocket because it's not a closed boundary. The tool wouldn't know what to chew out. A profile, the tool is just going to follow that line. That's it. Accept it. Go to Tool. Select. We could probably use any tool here. Let's use that 1/8 inch again. Same tool data, liked all that, coolant, etc. So select that one. Levels, the levels are similar. We've got to start, clearance, safety, upper. We need our profile depth to be the bottom because we're cutting through. Technology. Here's where you're going to get a different setup than the pocket. You're going to get some different parameters. All right. The first one is that you are going to care about is this depth type. Right now it's constant, so it's going to come down, take a cut, come down, take a cut. You could also make it helical if you had non-center cutting tools. Okay, we're going to keep ours constant. And then the really important ones are over here. We've got offsets, wall and floor, same thing, but they're grayed out. And the reason is because we haven't decided that we're going to rough this yet. So let's go ahead and rough it. That enables these offsets. The wall will keep it 0.05 thousandths. And we need to program in a step down. Let's say it's 20. We can make it equal. You can have your finish pass. So you can take this wall offset of 5 thousandths in multiple passes if you want. You could, if you did it in 2 passes, it would do 2.5 thousandths at a time. If you did it in 5 passes, it would do 1 thousandth at a time. We're just going to take that 5 thousandths in 1 pass. That's fine. We don't want a floor offset because there's no floor. All right. Now, extension overlap. This is going to help you if you were going to take the blend, if you're going to do that blending. So if I was going around this island here and I start here and wrap around here, maybe I want to go past that part of the island so that I can take out that blend mark. We don't have that situation here. So those are your most important ones. Your wall and floor offsets, rough and finish. Not going to use advanced all that often. And then link, again, has the lead ins and lead outs, and it has ramping if you need to ramp. In this case, I'm going to lead in and lead out. I want to lead in and lead out. I'm going to pick a different style. Let's say normal. So that's this normal, this right angle looking thing. The tangent extension, I'm going to make that. The reason I want to do that is I don't want my tool to plunge down right there. I want it to start off the part over here. So I'm going to make this extension at least the radius of my end mill. And I'm probably going to make it a little more. Let's make it the diameter of the end mill. And this normal length, I don't really care if it does this little 90-degree jog. So I'm going to make this normal length 0. Make the lead out the same as the lead in. And actually look at the lead out. If I end here, I've got to go this whole distance to get off the plate. So I'm going to make it not the same as the lead in. I'm going to make it quite a bit longer. Let's say 3/8 or maybe even a 1/2 inch. And let's see what that does. It didn't like a normal extension of 0, so let's give it something. And then let's simulate. Watch what we do here. Notice, because of my lead in, lead out, I started just barely off my stock. I'm so close to it though, I might want to increase that. But let's see what the rest of it does. Watch the tool. It follows that length. And look at the lead out. Didn't quite make it off the part. It jumps up to its clearance level, and it's going to go back for the next depth. Next depth, next depth, next depth. If you go to solid verify, notice our pockets are still there, and we'll hit play real slow. Takes 39, 59, 78, and then it's finish pass. 6 minutes, 33 seconds. Didn't look like it cut all the way through because of the graphics card. It really did. If you wanted to see it, you'd have to put in the little delta. And notice again, round tool, square corner, you're going to get a little fillet. All right, notice also that the tool followed the edge on the outside of the edge, which is what we wanted. But sometimes you don't. Sometimes you want to straddle the edge or go on the other side. You'll find that in it should be technology. Here it is, tool side. Notice the tool side said left. I can also do right or center where I just straddle a line. So if I did center, let's do that. Simulate. I'll zoom in here and you can see, watch where it goes. It is straddling that line. Sometimes you want to do that. All right, now let me show you a real common mistake. A lot of times I'm going to reselect the geometry not in a climbing configuration. So I'm going to edit, and I'm going to go the backwards way. I'm going to go to this chain and right click it and reverse it. You see how the arrow goes this way? Then I'm going to accept that. My tool side is still left, but watch what happens. I'm going to simulate this. Look at my tool.
Yeah, because it's gonna be contact left.
Yeah, see, it's on the inside of that line now. Okay? Now, you could force it to go to the outside of that line by going to right. And it'll go to the outside. But it's not climbing. So, one easy way that you pretty much can tell that if you're climbing or not is if your tool side is left. That almost always works. So if your tool side has to be right, you're probably not climbing. Okay? Questions there? Profiling. That's profiling.
Oh, I do have a question.
Yep.
So you only cut 2 of your sides, right?
Yep.
If you wanted to cut the other 2 sides, would you need to make another tool path, or can you just add a second geometry?
Great question. So I'm going to go edit this geometry and fix it so that it's correct. Save and calculate. That's a really good question. So we've now cut these 2 sides, right? And we want to change our clamps, and we want to cut these 2 sides. So, but the parameters are all the same. It's the only thing different is the geometry, right? So what you can do is you can right click, copy, and right click, paste. Now we have another profile written, but it's the exact same one. It has not been calculated. You can tell by this little star. Let's go ahead and edit it. What's the only thing we have to edit? The geometry. So we'll go to the geometry and edit. Yep. We'll go to New, and we'll select the chain that we care about. In a minute, I'm going to ask you another question. There's one more problem with doing this. We had already cut this part, so we're good. So I'm going to accept that chain. And then we should save and calculate. And we can simulate it. And there it goes. Same parameters and everything. Okay? That answers your question, I'm sure, right?
Yeah.
Now, one other problem. When you do that, there's one other thing you have to change. It does not assume that you want to be at the same depth. So you have to go back and make sure you catch your depth. All right? And then one other problem. So we've done these two sides. We've done these two sides with the same tool. But we needed to change the clamps. What's going to happen here? It's going to keep going and run into our clamps. How do we get it to stop? First one, edit, miscellaneous parameters, parameters list, stop, yes. Okay, save and calculate. You might forget to do that, and if you walk away from this machine, it will run into those clamps and crash it. So you should never walk away from a machine until you have an absolutely proven program that's run once already. Because you, if you're standing there looking at it, you can hit the emergency stop button and stop it. All right, other questions? Let's break for now. We're a little late. Let's come back at 10:15.